the transformation y equals f of bx, with the b multiplying the x inside the bracket here. We know this is a horizontal dilation of scale factor 1 over b. So we're going to use autograph again, and we'll look at just the sine and the tangent because the cosine is just like the sine. So what I have here is y is equal to sine bx, with at the moment the constant b, as we can see over here, set to 1. Now, we know that the sine has a period of 2 pi, and we can see that's one complete oscillation just here. And we know that this is a horizontal dilation, scale factor 1 over b. So if I turn b into 2, that means everything moves towards the y-axis. Everything halves its distance from the y-axis. So now, instead of the period ending at 2 pi, the period now of one oscillation ends at pi. So it reduces the period. The period for the standard y equals sine x has a period of 2 pi. But when we have y equals sine of 2x, that has a period of pi. Now, let's just look what happens when we change it to 3. So now we can see the period is 2 pi by 3, and we get 3 complete oscillations from 0 to 2 pi, and so on. So if we go up to 4, the period is now pi by 2. Now look carefully, because the sine is an odd function, which means it goes upwards here and downwards here. So in other words, it's not a reflection in the y-axis, it's a reflection in the y-axis, then a reflection in the x-axis. Now, if we make b into a negative value, look at what happens here around the y-axis. So I'm going to take b to -1, and you can see that now it goes up on this side and down on this side. So we have a reflection in the y-axis. Now, just while we're on this, I'm just going to put b back to 1, but then I'm going to change the step. So we'll go up in 0.1s. And I'm going to take this down so that b is 0.5. Now we know that this is a horizontal dilation, scale factor 1 over b. Well, if b is 0.5, 1 divided by 0.5 is 2. So everything's going to be stretched, so it's twice as far away from the y-axis. And note how we've only got half a period now in 2 pi, so the period now will have gone up to 4 pi. Now, I've changed this to y equals tan of bx, so y equals tan of bx. And at the moment b is set to 1, so it's the standard tan graph. And we can see that this section here goes from -pi by 2 through to pi by 2. So we have a period of pi. Now, let's just make this 2, and then we can see that this is reduced to pi by 2 as a period. And if we go to 3, that's even easier to see because we've got the axes here. So we can see now that one graph goes from, or one standard part of the graph here, goes from -pi by 6 to pi by 6, meaning a period of pi by 3.